The next topic we will talk is the definition of the power series. The definition of power series. And let's write the power series by x equals to the sum from m equals 0 to infinity am x minus x naught to the m's power. As before, we mentioned that power series is basically essentially a polynomial. Okay, so the am is called the coefficient. The x naught is called the center of power series. Okay, and you can rewrite this as you extend the all term instead of using the sum. So it will be a naught. A naught when m equals to 0, that will be 1 for this term. So a naught plus a1 x minus x naught plus a2 x minus x naught squared plus dot 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 until to infinity. And then we will go to the topic is how we can program this power series. What need to be careful when we see one of the power series. Okay, so this is the definition of the power series. The second part, we will go to the programming. And before we talk about the programming, I want to introduce one of the topic. It's called the power series radius test. Okay, because this is very important for power series, whether it can be programmed or not. This power series radius test essentially trying to test whether this power series at n step can be converged or not. Think about power series when you do the sum is basically when you add more term, it will be more closer to the true values. But this more term, if you go to nth term, it will go to infinity. Then this power series will go to infinity. It couldn't be converged. When we do the program, we have to first check whether this power series can be converged or not. If it couldn't converge, then we couldn't add, nth term going to infinity. So this we need to first test the power series whether it can be converged or not for the nth step. Then we do the program. Okay, so this is test the converge. If that can be converged, we will program for the power series. Then how we can do this radius test for the power series? Let's make an example. So hopefully you can get what is the radius test. So the first example, let's write a simple power series. So this is n factorial, sum of n factorial x to the n. This is one of the power series. And when we test, we are trying to see the n step, whether it can be converged or not. Basically, if you traverse to the n, that n step should be traversed to 0, then it will be converged. If the n step traversed to infinity, it couldn't converge. Then let's do limitation, because we want to see n is very big, so n is going to infinity. The n plus 1 step compared to n step. So n plus 1 factorial x to the n plus 1 divided by n factorial x to the n. Okay, let's see the absolute number. And that will be equals to limitation n going to the infinity. After this, doing the ratio n plus 1's ratio to n, refer to n, then that will be n plus 1 times x. So this is the ratio between the n plus 1 step compared to the n step, and that is equals to n plus 1 times x. And we know that n is traversed to infinity. Then for this case, if my x is equals to 0, the limitation n traversed to infinity, n plus 1 times x will be equals to 0. because your x equals to 0. If my x is not to 0, the limits n converts to infinity, n plus 1 times x will convert to infinity whenever what kind of x you are choosing. It will go to infinity because your n is going to infinity. So for this problem set, there is a condition. When your x equals to 0, then this whole term will go into a converge set. But if your x is any other number besides 0, it won't converge. So you have to test, you have to check this power series. If x equals to 0, you can program. If x is not, you couldn't program. Okay. Then let's make another example, the second example. The second example, let's make a power series, which is sum from m equals to 0 going to infinity. Okay. And you have am x minus x0 to m's power. Okay. So this is very traditional power series is exactly our definitions. Okay. For the power series. And let's see the radius test. The radius test is compared to n step, n plus 1 step with your n step when your n is going to infinity for the limits. Okay, so the limits when I'm going to infinity, the m plus 1 step will be a m plus 1 x minus x naught m plus 1 divided by a m x minus x naught m, right? And if you do this ratio, it should be equals to limits m going to infinity, am plus 1 divided by am, this coefficient ratio, times x minus x naught. Okay. And so this is our ratios between m plus 1 step referred to m step. And if I gave a condition at the initial that my am equals to 1 over m factorial. And you can see if am equals to 1 over m factorial is essentially represents the exponential functions, because exponential e to the x will be x divided by m to the factorial. So this is essential will be an exponential function when the coefficient is 1 over m factorial. And let's see whether this can be converged or not. So if am equals to 1 over m factorial, then this part will be equals to limit m going to infinity, okay, 1 over m plus 1 factorial over 1 over m factorial times x minus x naught, okay? And that will be equals to basically m factorial divided by m plus 1. So it will be limit when I'm going to infinity and 1 over m plus 1 x minus x naught, the absolute number, okay? So when you m plus 1 is, okay, is when the m going to infinity, 1 over m plus 1 will be going to 0 and times x minus x naught. So when you x minus x naught is over negative infinity or positive infinity, it will all converge because this 1 over m plus 1 is going to be 0, okay? At all x will converge because this term is 0 essential, okay? So for all the exponential functions, you can program because it can go to 0 at m plus 1 step. It will all converge with all the chosen x value, okay? Then the next, we will make a third example so that you will be more clear about this power series convergence. The third example, what we can do is fx is equals to sum from m equals to 0 going to infinity minus 1 divided by 8 to the m's power times x times x to the 3m's power. Okay, this is another power series. And let's do a substitution first so that it will go to some variables to the m's power. Then t is equals to x to the third. So we can rewrite this fx going to be xt, ft will be sum of m from 0 to infinity minus 1 over 8 to the m's power t to the m's power. So this is power series with the variable is t, where the t is equals to x to the third. And let's see for the m plus 1 step compared to m step, what is the radius? So the limits from m towards to infinity, that the m plus 1 step will be minus 1 over 8 m plus 1 t to the m plus 1 divided by minus 1 over 8 m t to the m, and the ratio will be equals to the limit when I'm going to infinity minus 1 over 8, okay, minus 1 over 8 times t, okay. And when this limit will be smaller than 1, when this limit will be smaller than 1, that means you are converging smaller and smaller and smaller for the m plus 1 order. Then this t will be smaller than 8, right? That means you x the cube will be smaller than 8, x will be smaller than 2. That means x should be in the range over minus 2 smaller than 2, okay? So as you have the power series, you first need to test the radius. If the radius of the m plus 1 step as compared to m step is the absolute number of that radius is smaller than 1, then that means it will be converged. If that is over 1, it won't converge. Okay, so essentially for the radius test, we will compare to the step of n plus 1 over step of n, and if that radius is smaller than 1, it will lead to converge. If that is bigger than 1, it won't converge because non-converge, because your n plus 1 step is always bigger and bigger and bigger towards to infinity. And that is how we do the radius test. And after we do the radius test, we can decide whether we can program this power series or not.